Does your mathematics curriculum require you to teach the rules of divisibility? And have you ever wondered why, or maybe why not? There are many reasons why we have students learn the rules of divisibility. For example, it makes it easier to find a common denominator to help you add and subtract fractions. It also makes it easier to simplify fractions when you know the numerator and denominator are both divisible by the same number. You probably know one or two basic rules of divisibility. For example, you probably already know that a number is divisible by 5 if the number in the ones place is divisible by 5. But can you explain this rule using concrete materials? In this episode, I'm going to be using base 10 blocks and sharing mats to help your students truly understand the rules of divisibility that are generally taught in elementary or primary schools today. And if you stay to the end, I'm going to share a rule of divisibility that I bet you don't know. I'm going to make this easy for you and start with the most basic rule, and I'll move to the more complex. Here I have a sharing mat for division by 2, and I have the number 700s, 5 10s, 6 1s, 756. And I'm going to use this number for each of the rules. And for each of the rules, I'll always start by looking at the greatest place first. What will happen when we divide 100 by 2? Will there be anything left over? No, there won't. We know that these will divide evenly by 2. So we have to look at the tens place. What will happen if we divided 10 by 2? I could have these out as ones and do that, and it's good for the children to actually do that. If they do it, you'll find there's no remainder. They always share out evenly. So we have to look at the ones place. Will this divide by 2? They either will or they won't. So we have to conclude that a number is divisible by 2 if the number in the ones place is divisible by 2. It doesn't matter how many hundreds you have, how many tens you have, you always must look at the ones place. Even if I have thousands on this end, it does not matter because we know 1,000 is also divisible by 2. You must look at the digit in the ones place. Before I go any further, I want to say that I was very intentional with the language I used to describe that rule of divisibility. I did not say a number is divisible by 2 if it is even. I did not say a number is divisible by 2 if the last digit is either 0, 2, 4, 6 or 8. Both of these may cause a misconception. Look at this number for example. Its last number is 2. Is it divisible by 2? The rules of divisibility only apply to whole numbers. Now look at this chart. It now shows you what we know about the divisibility rule for 2, and I'll continue to complete this chart as we progress. It turns out we can use the same logic for the divisibility rule for 5. Here we have a sharing mat for 5, and we have the same starting number, 756. Just like the divisibility rule for 2, I can divide these by 5 and there'll be no remainders. So we move to the tens place. But we know we can divide these by 5 as well and there'll be no remainders. So we need to look at the ones place. A number is divisible by 5 if the digit in the ones place is divisible by 5. In this case, the digit is 6 and it's not divisible by 5. So only numbers that have 5 and 0 in the ones place are truly divisible by 5. Now you might be wondering, is 0 divisible by 5? Well, we can prove that using the inverse operation, which in this case is multiplication. Let's look at these number sentences together. I've created a pattern of number sentences to make this easier to see. 20 divided by 5 is 4 because 4 times 5 is 20. 15 divided by 5 is 3 because 3 times 5 is 15. 10 divided by 5 is 2 because 2 times 5 is 10. 5 divided by 5 is 1 because 1 times 5 is 5. And 0 divided by 5 must be 0 because 0 times 5 is 0. You can place a number in that last sentence to make a true statement, proving that 0 is divisible by 5. Now what about the divisibility rule for 4? Here we have a sharing map for 4, and we have our starting number 756. 756. What do you know about dividing 100 by 4? As adults, we know we can divide that evenly by 4 and there'll be no remainders. For all these rules, I would encourage you to allow the children to actually share them out with blocks. I'm skipping that step for you because you're an adult. Now what about the tens? Can I divide that evenly by 4? You and I both know that you can't. There's going to be a remainder. So the divisibility rule for 4 has you look at the digits that are in both the tens and ones place. We don't need to look at the thousands, the hundreds. We know they're divisible by 4. You have to look at the numbers in the tens and the ones place. And again, I would encourage you to have your students share them out. Whoops, I'm going to have to trade this 10 for 10 ones. And when I have that, I can share these out and I can see that 56 is indeed divisible by 4. So 756 is divisible by 4. Now, let's look at our summary chart. Here you can see the rule for divisibility by 5 and now the rule for divisibility by 4. Now let's look at the divisibility rule for 3. Here we have a sharing map for 3, and we have 756, the same starting number. What do you know about dividing 100 by 3? Well, if we shared it out, we would see that this has 1 left over. And as adults, we know that 99 is divisible by 3, therefore there's always 1 left over. So if I shared these out and took it away, I would have 1 left over. And that means for every one of these blocks, I'm going to have a 1 left over. So 1, 2, 3, 4, 5, 6, 7. I have 7 ones left over for each of these that I shared out. Now let's look at our tens. You and I again both know if I shared these out, 9 is divisible by 3. So again, I'm going to have 1 left over. So if I shared that out, I got 1 left over. If I share the next one out, I have 1 left over. And the same is true for the other tens. So I have 5 of these left over. And at this stage, you might be noticing that the number left over, the remainder, matches the digit that we had in each place. We had 7 hundreds, now we got 7 ones. We had 5 tens, now we got 5 ones. And we already had 6 ones. So all I got to do is share these out evenly. If I keep sharing these out like this, we would see that this number is divisible by 3. And look at that. So if the sum of the digits, when you add all these together, if you can divide that out by 3, you know this number is divisible by 3. Now we can apply the same reasoning for the divisibility rule for 9. Here I have a sharing map for 9, and again 756. What do you know about dividing 100 by 9? We both know that 99 is divisible by 9 and there's going to be 1 left over. Again, I would encourage your students to actually share it out. I'm skipping that step here. For each of these, there's going to be 1 left over. So I'm going to remove these and place my 7 ones left over here. Now let's start the tens. Again, you and I both know that 10 is not divisible by 9. There's going to be 1 left over for each of these blocks. I'll remove that and add a 1. And I'll do the same for the other 4 tens. Now I have a total of ones blocks. Each of these remainders reflects the digit that was in the place of the original 3-digit number. 7, 5, and 6. I can just combine these. And if these digits, these ones, are divisible by 9, my entire number is divisible by 9. Let's check. So a quick share will tell us that 18, the 18 units blocks, the 18 ones blocks, do share equally by 9, so my entire number, 756, is divisible by 9. And our chart here now shows the rule for dividing by both 3 and by 9. Now that just leaves the divisibility rule for 6. You can see my unique sharing mat for 6 and 756. Look at what's happening. You can tell that I'm going to have to share this out by 2, and once I have a share for 2, divide that by 3, and that gives me my 6 equal shares along the bottom. Now what does this mat tell you about the divisibility rule for 6? I would want your students or child to put that in their own language. Something along the lines of a number is divisible by 6 if it's divisible by 2 and by 3. So let's look at our number, 756. Without sharing the blocks physically, we know this number is divisible by 2 because the number in the ones place is divisible by 2. Now what about 3? We have to add the digits in each place. 7 plus 5 is 12, plus 6 is 18. We know 18 is divisible by 3, so the entire number, 756, is divisible by 3. So this number is divisible by both 2 and 3, so we can safely say it is also divisible by 6. Now I've added that rule for the divisibility by 6 on our chart, and I've given that chart to you in the links of this episode, and I've also given you all the sharing mats in the links. Now, for that divisibility rule, which I suspect you don't know, I actually found it in this old book by Dixon. It's called The Theory of Numbers, and it has a 1919 date on it. And it's the divisibility rule for 7. For you, I'm going to explain this rule just using symbols, because it is not a rule we generally explore in the elementary or primary school, but it is really interesting. Look here at our number again, 756. You double the digit in the ones place, so double 6 gives you 12. You then subtract the 12 from the number formed by the remaining digits. The remaining digits are 75. So 75 subtract 12 gives you 63. Now because 63 is divisible by 7, the entire number is divisible by 7. Let's look at another example. Here we have 532. Again, double the digit in the ones place. Double 2 is 4. Subtract 4 from the number formed by the remaining digits in our original number. So remaining digits 53, so 5 and 3, so 53 subtract 4 gives you 49. And because 49 is divisible by 7, the entire number is divisible by 7. So this is what I want you to do. 1, familiarise yourself with all those rules of divisibility that I've provided for you on a summary chart in the links here. And 2, use the sharing mats I've given you with base 10 blocks to explore all the rules of divisibility with your students or child. You want them to discover the rules rather than just giving them another rule which they don't understand or remember. And 3, if you got value from this episode, go ahead and give me a thumbs up, give me some valuable comments, and subscribe today so you never miss another learning opportunity with me. See you next time.